Hello and welcome once again to Audi ITV, live from Ingolstadt. Welcome to today's second show, focusing on the 1.4-litre TFSI engine. And welcome back Ralf Schmidt from Audi Service Training. Did you enjoy your lunch break?
Certainly.
Like always. We were busy this morning. You gave us an overview of the engine components. We got into detail on some things. The cooling system, oil pump, ventilation, etc. We noticed that our viewers had lots of questions for us. We answered many of them, but one question stood out: blocking the crankshaft.
That question involved this new tool here, locking pin T10340. That's why we're next to the engine. I rotated it so we can get a good look at the crank drive. I've already screwed this pin in a bit. I'll turn it until it's snug. Then we can look at this spot on the crank web. We see that the tool isn't screwed into the crankshaft. Instead, it functions as a stopper. It's tightened with 30 Newton-meters of torque. This blocks the crankshaft, keeping it from moving in one direction, in the direction the engine rotates. I could turn it backwards. Actually, I can't because of the camshaft bar. Once again, the tools for determining the TDC of the first cylinder should be used. By that I mean the dial gauge and the spacer sleeve with the long sensor should be used regardless.
That rounds off this morning's show. Let's turn to what we'll be serving up now.
We'll be dealing with the topic air supply. We'll talk about the turbocharger and the fuel supply and engine management systems. We'll finish with maintenance and service information.
Well, let's get the ball rolling. Air supply and turbocharger. A quick question to start. Is the 1.4-litre TFSI the engine that comes as standard in the A3?
No, it isn't. We touched on this in the first show. The 1.6-litre engine is standard. It does have more displacement, but the performance data for the 1.4-litre engine is far better. It's a hallmark example of the concept of downsizing. This engine is small, it performs excellently, like an engine with more displacement. The advantage of this is that these engines lose less friction power than larger engines, and this lowers fuel consumption. Emissions are something we're very concerned about nowadays. CO2 emissions are a major issue, and downsizing concepts are gaining more and more momentum.
We'll get to CO2 emissions later. When was the engine launched?
Last year.
Third quarter of 2007. Let's get down to brass tacks. The intake connection pipe in the cylinder head.
We've prepared a diagram. Here we have a cross-section of the cylinder head. We're looking at a combustion chamber in blue. The blue represents the air that's flowing in.
It flows in from the left.
And you can see that the air has already begun to circulate around in this tumbling motion. That happens automatically due to the design of the intake port. The port on this cylinder head is very flat and it's somewhat tangential. We also have a port partition plate which divides the port into an upper and a lower section. What we no longer need is the tumble flap. It has been removed. That's thanks to the design of the intake port, its flatness, and the fact that it runs tangentially. In addition, we have a masked inlet valve. The masking is designed so the inflowing gas, that is the inflowing air, is moving in this tumbling motion. To achieve this, it's no longer necessary to use a tumble flap to close the bottom section of the port, so air can only flow through the upper section.
It happens automatically.
This also improves the mixture formation.
Any special features on the turbocharger?
Let's go over to our exhibit. We'll take a look at it. At first glance, you might notice that this turbocharger is very small and compact. We have the entire module, manifold, turbocharger, and the compressor module, all together as a unit. It can't be disassembled. In the end, that means that if any of the components break, the whole unit must be replaced. I'll give you a quick tip. When you've unscrewed the unit and go to screw it back on the cylinder head, you have to be careful when tightening the manifold screws, the copper screws and nuts that we always use. Make sure that you fasten them using the exact torque specified. If they're fastened too tightly, it's possible that tension could build around the manifold, causing thermal cracks.
We don't want that.
It ruins the manifold.
As you mentioned, the turbine has a very small diameter. How small is it?
It's 37 millimeters, so it's a very small turbine. If we take a peek inside here, we can see the turbine wheel. The tiny component is quite easy to recognize. That definitely makes sense because it makes the response of the turbocharger very spontaneous.
Now would be a great time to look at the performance graph. You brought one for us.
Exactly. Here we see the torque and performance curves. The red line is the performance curve. We've mentioned the performance data, 125 horsepower or 92 kW at approximately 4,500 revolutions. The blue curve is the really interesting one. It's the torque curve. The beginning of the graph depicts torque when the engine is idling, and when the engine speed is about 1,250 RPMs, it has reached 80% of the maximum torque. And at 1,500 RPMs, the engine has already reached maximum torque, and that is maintained until the engine exceeds 4,000 RPMs. So the engine achieves maximum torque while running at a wide range of RPMs. So when we look at this curve, it reminds us a bit of the torque curve for a diesel engine.
That's true. We spoke briefly about what to do if the turbocharger is broken. Is it possible to replace any parts in that area?
It is possible to replace some parts. We'll point them out to everyone on this module here. To start, this electric wastegate valve can be replaced. There's more. I'll turn the module around. Here we have our vacuum actuator, which controls the charge air pressure. This can be replaced too. And above the vacuum actuator we have this electric valve. It controls the vacuum actuator, and that can be replaced also. Those three components can be replaced.
The charge air line is also important. There are some changes to explain. It has a much shorter path.
Let's go to the engine for a look.
To see the shorter path, we'll have to tread one ourselves. All right.
Okay. I'll turn it around so we get a better view of the turbocharger. It starts up here, turbine, compressor rotor, and here is where it was partitioned. Until now, the charge air line started here. It ran from here towards the front end. Because, as we know, the charge air cooler is there. It must return from the front. That means a number of lines. That's a very long path, and it contains a significant volume of air that must be compressed. That's no longer the case. The charge air has a shorter path. It starts at the compressor outlet, then proceeds directly over the engine and ends up on the other side. We arrive at the intake manifold. It has the throttle valve in front of it. It enters the intake manifold, goes past the charge air cooler, and we land at the engine.
That cuts the air volume.
By more than 50%.
What does that change?
Because of the big reduction in air, there is less air to compress. That leads to a major improvement in the engine's responsiveness. The driver no longer feels any turbo lag at all.
So greatly improved engine performance. Thanks for that. Now we change topics, moving on to fuel supply and engine management. Luckily for us, Ralf Schmidt is still here. What do we have to say about fuel? Consumption is a major issue, but you mentioned another big one, CO2 emissions.
What should we start with? How about consumption? To start, the engine requires fuel with an octane rating of 95. Of course, it can be run on 91 octane fuel without any problems, for as long as that's possible. The NOx control system compensates for that. We calculated urban, extra-urban, combined consumption and arrived at 15.6 kilometers per litre. That could be improved upon a bit if I have the chance to order that engine with a twin-clutch gearbox.
But it's quite good already.
It certainly is. On to CO2 emissions, a major issue, one that interests everyone. This engine has emissions of 154 grams per kilometre.
Let's explore the fuel supply system more thoroughly. What developments are there? What should we know?
Basically, both the low-pressure and high-pressure fuel systems are now supply-on-demand fuel systems. The low-pressure system has an electric fuel pump in the fuel tank. The engine control unit activates the pump via the fuel pump control unit. And this delivers just enough fuel to keep the engine running smoothly. It only has a fuel supply line and no fuel return line. When constructing this low-pressure fuel system, we did not install a fuel pressure sensor. That brings us to the high-pressure fuel pump, here on the top of the engine. This pump is new as well. It's what we call third generation because it employs a new regulating concept. We'll get to that shortly. This pump is driven by the intake camshaft with a 4-lobe cam. That's also new. It used to be a 2-lobe cam. That would require an increased stroke.
We mentioned that this morning, the new high-pressure air pump. I mean high-pressure pump. How does the third generation differ to the second generation?
The 4-lobe cam drive system, the reduced stroke of the pump, it's all more contained. That eliminates pressure peaks in the fuel rail. The most significant change is the new regulating concept. And another thing I should mention, I have the rail here too. We can see the fuel injectors here on the rail, or rather high-pressure injectors. The rail presses them tightly into the cylinder head. We also have a high-pressure sensor. One thing we no longer have in the fuel rail is the pressure limiting valve. It's not there. It isn't located here anymore. The pressure limiting valve has moved into the high pressure pump. It's triggered when the fuel pressure exceeds 140 bar. It opens and the fuel flows back to the high pressure pump feed.
Very interesting. What happens if the regulating valve fails?
First, a word about the valve. Up to now, it worked as follows. Fuel was first delivered when the valve was supplied with current. Now it works the other way round. Fuel is now delivered at complete capacity when there is no current. On the other hand, that means service teams have to be careful, because that means if the valve fails, delivery is at full capacity.
How can the driver recognize if it's faulty? What happens?
If it fails, fuel pressure will be at 140 bar, because the pressure limiting valve is the only thing that restricts it. The engine control unit registers the jump in pressure. The fuel pressure sensor detects 140 bar instead of 100, which is the upper limit. Then the control unit prompts an emergency program. The rise in pressure causes an adjustment of the injection timing, lowering the amount of fuel delivered and the RPMs. The driver would notice that engine speed is limited to 3000 RPMs.
We talked a lot about high pressure. You have to reduce the pressure to work on the system. How and where should I do that?
It used to be that you could disconnect the connector from the pump. You had to read measured value block 140 by connecting the tester to get the reading. You could check the rail pressure. If it was at around 8 bar, then you shut down the motor. The procedure is now basically the same, except now when I disconnect the connector, I can immediately see block 140. I can see the pressure can reach up to 140 bar, thanks to the new regulating system, the pump. So I have to use a different procedure to reduce fuel pressure.
What do you do?
I hook up the tester, look at measured value block 140, then I go to the fuse box on the vehicle and I remove the fuse that is responsible for the power supply to the fuel pump control unit. This stops the fuel pump from delivering fuel from the tank. Then I wait until the fuel pressure sinks to 8 bar and shut off the engine when it does. Don't just let the engine run out. If you do that, it begins to sputter, and there's no pressure in the pump. But there is the danger that this juddering and sputtering will damage the catalytic converter. We don't want that. So be sure to shut down the engine at around 8 bar. Open up the high pressure system when you've done that. I advise you to cover the area that you want to open with a rag. That's best done here on the pump. Then open it there and we're set. If you wait too long, the pressure can build up again. If you open it, there's a risk of injury due to the high pressure. We want to avoid that.
Most definitely. Let's move on to another area. You mentioned this engine has new injectors. Tell us about them.
The new injectors now have 6 holes, and the stream of fuel injection is now regulated differently. The point of doing that is so when the engine is warming up, during twin injection when the catalytic converter heats up, and when RPMs are very high and lots of fuel is being injected, the fuel cannot come into direct contact with the piston crown. And the new way of arranging the holes on the new injectors keeps the piston crown fuel-free. With this new system, we also prevent fuel from mixing with oil, or we reduce the amount. Some will always mix in.
Be careful when removing injectors.
That's why we have a display model.
Let's go over to it.
This is a cylinder head with 1 injector in it. Generally, when the engine has quite a few kilometers on it, you can just pull it right out. After a while, there would be carbon buildup. The injector would be stuck, and you'd need to use a tool to remove it. To do that, there's tool set T10133. It contains everything we need. And I would need this tool right here. That's tool T10133/15. It fits perfectly right onto here.
That's good.
I can't pull it out yet. To do that, I need a slide hammer. I screw the slide hammer on like this. This provides you with a good guide, and you can ease it out without using much force. Then it comes out like a charm. And the other tools in this toolbox have to be used to change the seals that need replacing. The Teflon ring must be changed every time it's taken out of the cylinder head. That goes for the O-ring too. There's also a springy supporting washer. That has to be replaced too, because it ensures that the injector rests nice and snugly in the cylinder head. And you find all the special tools you need for this right here in this toolkit. The procedure has remained pretty much the same, and it's explained in the repair manual.
Exactly. You can study it there in detail. On to engine management. How about the lambda control system?
We held back a bit there because we realized that wasn't an area we needed to invest in. We meet the Euro 4 standard as is. The sensors up and downstream of the catalytic converter are the same. They're slightly less expensive non-linear lambda sensors. And as we adopt Euro 5 standards, which will be in effect as of 2009, we'll continue to install the traditional lambda control system with a broadband sensor upstream and a non-linear sensor downstream.
How is the air mass determined? It's one of the main regulating factors.
I'll show you that using the engine.
Okay then.
This engine doesn't have an air mass flow sensor. Instead of those, we've installed pressure sensors. This engine management system is what we call a PN control. P is pressure, N is engine speed as the main control factor. We use pressure and air temperature to calculate air mass. For that purpose, this engine has two sensors of the same type. One is in front of the throttle valve, and the second sensor is installed inside the intake manifold after the charge air cooler.
Why two sensors?
Why two? Well, let me start by asking this. What happens when air flows through the charge air cooler? It gets cooler. As a result of that, the air mass changes as well. That's why it's better to check the air after it exits the charge air cooler. The sensor in front of the charge air cooler is there to control and regulate the charge air pressure system. And the sensor that is located after the charge air cooler measures the air mass of the air that is actually going into the engine. The two sensors also manage something else in the system. We heard this already on the first show. They're responsible for activating the electric coolant pump. The temperature variation between the sensors tells me how efficient the charge air cooling is. Using these values, I can use the engine map control system to activate the coolant pump, the electrically activated coolant pump.
That wraps up our discussion about the engine management system. Thanks, but you're not free to go yet. Let's look at the service information. You brought a diagram with a list.
Changing the oil is at the top of the list. It's possible to get a long life oil change. That happens at between 15 and 30,000 kilometers or biannually, depending on how the car is driven. We use motor oil with VW standard 50400. And of course, it's also possible to use normal oil and replace it at a fixed interval of 15,000 kilometers. For that, I use VW oil 50400, so I could basically use the same oil. I don't have to. I could also use VW 50200 oil. The engine oil quantity, including for the filter, is 3.6 liters. I can either extract or drain the oil. The warranty covers both methods. The air filter change comes at 90,000 kilometers, the fuel filter doesn't need changing, and spark plug replacement happens at 60,000 kilometers. I'd just like to note that neither the timing chain nor the ribbed V-belt need changing, both are lifetime parts.
Lifetime, as they should be. There are several ways to get more information if you need it. One's coming up on the show. We'll get to it soon. And you were writing a self-study program.
It will deal with the things we summed up briefly here and explain them in much greater detail. It will be finished soon. It'll be called SSP 432. And for the end of the year, we plan to hold an engine training seminar. a meeting for trainers. The trainers will receive training for all our various markets. They'll learn about this engine, for example. This engine training will eventually culminate in a specialist or expert training seminar. It will be offered externally. Mechanics can sign up to take part in expert training for this particular engine.
When will expert training take place?
That'll be sometime in 2009. It's not a pressing issue now. We want to see how the engine performs. After we do that, we can address the problems in a training session.
Great. Thanks for now. And dear viewers, if other problems should arise, or if you need more information, no problem at all. Just send a telegram. Ralf Schmidt is staying put, I hope. I do need answers. Send your questions. We'll be right back, live. Audi ITV is back. We're coming into the home stretch this Wednesday. Ralf, it's time for our viewer questions and your answers. Let's get started. What is the ID number of the dial gauge sleeve? It's a special tool, right?
I have it here. Amazing, isn't it? It's number T10170. It isn't just a sleeve, it also contains this measuring sensor. It must be run through the sleeve to get a connection with the dial gauge. The measuring sensor goes on to the piston. It's all described in the manual.
Great. Can you really run it on 91 octane? Really? An FSI engine?
Yes, you can. This engine assembly is designed to use 95 octane fuel. It can also run on 91 octane fuel. The knock control compensates for that, but you should expect less engine power as a result.
Okay. What about using E10 fuel?
This is a question I've been waiting for. This engine is of course compatible with E10 fuel. We'll have to see, but E10 fuel is supposed to be available starting next year. When it does come, this engine will be ready for it. It won't be a problem.
What's the top pressure in the turbocharger?
It reaches 1.8 bar in total. That's the air pressure plus 0.8 bar. That's the maximum charge pressure the turbocharger can produce.
Can injectors be replaced one at a time, or must it be the entire rail?
One at a time. We showed how they might get stuck in the cylinder head. If that happens, we need our special tool set to remove them. You can change them individually.
Do you have to vent the fuel system after repairs?
This fuel system vents itself. That isn't an issue. The electric fuel pump in the tank starts and vents the air up to the high-pressure pump. The high-pressure pump takes care of everything else. Pressure builds up inside it and the air cushion is pushed out via the injectors.
Precise answers. Next question. We thought the engine had a mechanical water pump.
It does have one. It keeps the main cooling circuit running. And the electrically powered pump, the coolant pump, is responsible for the charge air cooling circuit, including the turbocharger. It also has another function. It takes care of run-on cooling to protect the turbocharger after the hot engine has been shut off.
Mr. Kölmel sends his regards and asks, doesn't the charge air line cool less effectively right next to the engine than it would if it were cooled by the airflow?
No. The cooling system works so efficiently that the maximum temperature difference upstream and downstream of the charge air cooler is 20 degrees Celsius in relation to the outside air. So we managed to cool it almost to the outside air temperature.
Okay, on to the next question. Could you repeat the number of the tool for injector removal?
Sure, we have the tool set here. The number of the tool set with all the required tools is T10133. What we need from it in this specific situation is this hammer, T10133/3, and the sleeve that goes with it, which fits perfectly onto the injector. T10133/15. Use this to remove it.
The tool set number is key.
It's all there, all you could ever need.
An all-inclusive package deal, as it should be. Another question. Could you say again where the air mass sensor is?
There isn't one, because, as we mentioned, we now have a PN control system. We've covered that with 2 sensors, which is also new, with 2 pressure and temperature sensors. One was installed upstream of the throttle valve and the other downstream of it after the charge air cooler.
Good. Okay, now you read this question and I'll answer it.
What's the question? What kind of oil is 50400?
Oh, tough one. I know. What about you?
That's easy. It's our long-life oil.
Next question. Why are 2 types of oil specified, long life and normal? Why are 2 types of oil listed?
In comparison to long-life oil 50400, oil 50200 is the somewhat more economical oil, but it has a replacement interval of only 15,000 kilometers or 1 year.
Fantastic. Is there another question? I believe that's all for now. Thank you for answering our questions. If you think of new questions or yours was missing, don't fret. You will find everything summed up on Audi ITV Net with Ralf Schmidt's answers. He still has work to do.
I'll do my best.
I expect nothing less. You can download or view this program again at Audi ITV Net. And don't forget to evaluate this lovely little program. Go to Quality Feedback on Audi ITV Net to fill out the online questionnaire. The 2 of us will be back again next week. We'll be here next Wednesday. In a fortnight, we'll be talking about climate control in Audi vehicles. That's all from us for now. Ralf, thanks for all the information, and thank you for watching.
Thanks, and enjoy your evening.
Danke.